Right now, as you watch this, our galaxy is being hunted, not by anything alive, not by a force we can stop, but by gravity, patient, invisible, and absolutely relentless. There are galaxies out there on a collision course with the Milky Way, and the question is not if they will reach us. The question is which one gets here first. The answer is going to change how you think about the night sky forever. Our galaxy does not sit alone in space. It is part of a family, a cluster of galaxies astronomers call the local group. Around 50 galaxies in total, bound together by gravity. Two of them dominate. The Milky Way, home to somewhere between 100 and 400 billion stars. And Andromeda, bigger, heavier, and heading straight for us. You can actually see Andromeda with the naked eye on a dark night. That faint smear of light, barely noticeable, about 2.5 million light-years away. But it is moving toward us at roughly 110 kilometers per second. That sounds terrifying, and at human scale it is. But space is vast enough that even at that speed it takes time. A lot of time. Andromeda is the heavyweight. It contains roughly 1 trillion stars, about twice as many as the Milky Way. And in approximately 4.5 billion years, it will collide with us. Now here is the part people always get wrong. When galaxies collide, the stars inside them almost never actually crash into each other. The distances between individual stars are so enormous that they pass through like two swarms of bees flying into each other. The real violence comes from gravity. Clouds of gas get compressed. New stars ignite in enormous bursts of formation. The shapes of both galaxies get torn apart and rebuilt into something new. The result, billions of years from now, will likely be a massive elliptical galaxy. Astronomers have already nicknamed it Milkomeda. But Andromeda is not the first. Look south on a clear night from the right latitude and you will see two glowing patches in the sky. They look like detached pieces of the Milky Way. They are the Large and Small Magellanic Clouds, two dwarf galaxies that orbit our own. For a long time, astronomers thought they were gentle companions, satellites circling us safely, but the picture has changed. Recent measurements suggest the Large Magellanic Cloud is moving fast. Very fast. Fast enough that some models predict it could fall into the Milky Way in as little as 2 billion years, possibly sooner. Here is the jaw-dropping part. The Large Magellanic Cloud is not small, it contains tens of billions of stars. When it hits, it will not just merge quietly. The impact is expected to send a shockwave through the entire Milky Way, rippling the disk, flinging stars off into intergalactic space and possibly disturbing our own solar system's position. There is even a small but real chance, around 1%, that the collision could send our solar system hurtling toward the supermassive black hole at the center of the Milky Way. Not a comfortable thought. The good news, and there is good news, is that even if that happens, the solar system itself would likely survive intact. The stars are too far apart for Earth to be physically struck by anything. To understand why the Large Magellanic Cloud is falling inward, you have to know about dark matter, the stuff we cannot see, but which makes up most of the mass in the universe. The Milky Way is surrounded by a massive halo of dark matter, and that halo acts like a gravitational trap. Anything that gets close enough gets pulled in. The Large Magellanic Cloud wandered too close, and now, like a marble rolling toward a drain, it is falling inward. Gravity does not negotiate. Some models suggest it has already made its closest past approach and is now on an inward spiral. The collision clock has started. Zoom out even further, and the picture gets stranger. The local group itself is being pulled toward a massive structure called the Virgo cluster. And beyond that, toward an even larger gravitational anomaly, astronomers call the Great Attractor. Everything is moving. Everything is falling toward something. The universe looks static from our tiny vantage point, but it is anything but. On cosmic timescales, galaxies are like droplets of water rolling across a surface, finding each other, merging, growing heavier, pulling in more. What we call the night sky tonight is a snapshot. One frame in a film, billions of years long. None of this happens on any timescale that touches human life, or human civilization, or anything that has ever existed on Earth. 2 billion years is longer than multicellular life has existed on this planet. 4.5 billion years is roughly the entire age of the Earth. So in one sense, none of this is our problem. But in another sense, the sense that matters for understanding where we are in the universe, it is everything. We live inside a galaxy that is already in the middle of a slow, inevitable gravitational story. The Magellanic Clouds are falling toward us. Andromeda is closing in, and in the deep future, all of it will become something else entirely. So which galaxy will swallow the Milky Way first? Almost certainly the Large Magellanic Cloud, predicted to arrive roughly 2 billion years before Andromeda does. A dwarf galaxy, by cosmic standards, but still carrying tens of billions of stars and enough mass to shake our galaxy to its core. It will not swallow us cleanly. These are not neat events. They are drawn-out, chaotic, beautiful catastrophes that unfold across hundreds of millions of years. The Milky Way will absorb it, grow from it, and then, billions of years later, be absorbed itself into what becomes Milkomeda. Every collision seeds new stars, new possibilities. The universe does not end things. It transforms them. The galaxy you live in tonight will not exist in the same form forever. But what it becomes will carry the same stars, the same atoms, the same matter, rearranged by forces that have been running since the beginning of everything. We are not at the end of a story. We are somewhere in the middle of one that is still being written. And that, honestly, is the most remarkable thing of all. If you want to keep exploring questions like this one, questions that make the universe feel both enormous and somehow more alive, subscribe. There is a lot more to cover. Next time, we are asking a question that keeps physicists up at night. What actually happens at the center of a black hole, not around it, not near it, but at the very point where physics breaks down completely? That one is coming soon.